So guys, I'm going to have this video in a very nice form. I'll upload it on my YouTube. So you will get it from there, but I'll send you the link in the group so that you follow it up on YouTube. But there we did so many questions and almost most of the tutorials we did them last year also. And they were the same, in the same channel. And access is strictly by subscription. I just subscribe for free and access them. Okay, so we go to question 8. Three letters are selected at random from the word biology. Biology. Find the probability that the selection does not contain the letter O. So, three letters are selected at random from the word biology. So first to count, how many do we have? 1, 2, 3, 4, 5, 6, 7. So 7 to 3 is the number of possible arrangements. This is 7 factorial over 3 factorial 4 factorial, which is 7 by 6 by 5 by 4 factorial over 3 by 2 by 4 factorial. So we cut here 6 there, so we have 35. For 35 ways of picking 3 letters from the word biology. Now, because we have talked about a specific letter does not contain the letter O. What does it mean? We have 2 groupings now. So we have 1, 2, 3, 4, 5. So we have 5. The probability that there is no O is equal to 5. Choose 3 and 2 to 0 over 35. 2 to 0 is just 1. Then 5 to 3 is 5 factorial over 3 factorial. 5 minus 3 is 2 factorial over 35. This is 5 by 4 by 3 factorial over 3 factorial, 2 factorial. So those will cut there. This will give us a 2 over 35. So we get 10 over 35, which is 2 over 7. We divide by 5 there. Then B, so this was A. B contains the 2 O letters. So the probability that O is contained in the selection. Remember, if you contain O, we only have 2 O's. So if they're all contained, so we'll do that. Meaning from the other letters, we'll only pick 1 out of 35. That will be 5 factorial over 1 factorial, 4 factorial over 35, which is just 5 over 35, which is 1 over 7. That one was this. Unless otherwise, if you have a question, you're free to ask. So to repeat, we are saying since we have 7 letters altogether, and the question is about letter O, meaning we have 2 groupings. Those that are letter O's, there are 2 of them, and the remaining 5. So if there is no O, meaning we'll pick all the 3 letters from the 5. So we'll have 5 to the 3 multiplied by 2 to 0, meaning there will be no O. But 2 to 0 is just 1. So 5 to 3, so get it there as 5 factorial, 3 factorial, 2 factorial. giving us this, so that we get 2/7. And then all is contained. In fact, the question says all the two data alls are contained, meaning from 2 alls, we get all of them. Meaning from the other data, we just need 1 because the selection needs 3. So if you already have 2, you're just looking for 1. So you pick 1 and put there, and then put everything together like that. Okay. So question 9. Question 9. In a class of 24 girls, let me do it on another page. In a class of 24 girls, 7 have black hair.
Excuse me, sir.
Hello.
I was having connection
Yes, you're having
problems. A whole lot of question 8 on the class.
So they explain question 8 in the version of question 9. And then you see what is happening. Okay. So what do you do? Question 9. The class has 24 girls. Now the distinction is that we have 7 with black hair. A, if 2 girls are chosen at random from the class, 2 girls are chosen at random from the class, find the probability that they both have black hair. First thing, you know, out of 24, you must choose how many? 2. This is 24 factorial over 2 factorial, 22 factorial, which is 24 by 23 by 22 factorial over 2 factorial by 22 factorial. So we cut here and 2 there 1, 2 there 12. So we get 12 by 23, but that's just 12 by 23. That's 276. I have to calculate that here. I'm being fine. 1. If 2 girls are chosen at random, so I've already found the NS, meaning the number of possible the number of possibilities. Find the probability that they both have black hair. Remember how many have black hair? The probability they both have black hair. Remember, we are dealing with 7 here with black hair, so we are choosing from that. Meaning, if you choose from the other, 24 minus 7 is 17. So it will be 17. You choose nothing over 276. This is going to give us 7 factorial over 2 factorial 5 factorial over 276. This is 7 by 6 by 5 factorial, 5 factorial by 2 over 276. So that this here 1, this here 3. So we get 21 over 276. You can simplify. It looks like you can simplify. Let me punch 21 divided by 276. That's given me 7 over 90. So you can simplify that far. Or you get it in decimal, 0.076. The data must be statistical in nature. 2. Neither has black hair. So neither has black hair. Meaning from black, we just want 0. 17, we'll pick 2 over 276. 7 to 0, that is 1. 17 choose 2. Yes, sir. Okay, we'll do it minus 17 by 16 by 15 factorial over 2 factorial. 15 factorial is 17 minus 2. So this will go. That guy there will give us 8 over 276. That will be now I can punch. 17 by 8 to get 136 out of 276. And then this guy divided by 276 is 34 out of 69. Simplified. B, so it's the choose, just the normal binomial calculation that we are doing here. Not yet stressful. So hope it's okay. Okay, so B, since there are no questions, if 3 girls are chosen at random, find the probability that more than one will have black hair. Now we have changed. So here, look, Charu, 17 to 0, we are told the 2 that we are picking must have black hair. Now, black hair is, we only have 7 in the class that have black hair. So we're saying from 7 black hair, we'll choose 2. Meaning, from the non-black hair, we'll choose nothing because we only want 2. That's why we have said 17 to 0. The reason why here it's 7 to 0 is because we are saying from the black hair, we need nothing. It must only come from the non-black hair. Okay, so now we have a different condition here. The NS has changed. We now want to choose out of 24, we must choose a 3. Meaning we have 24 factorial over 3 factorial, 21 factorial. That is 24, 23, 22, 21 factorial over 3 by 2 by 21 factorial. These will cancel, and then we'll remain with, this is 6, 4 there. So we have 22. We have 22 by 23 by 4. That's 20, 24 over. Remember, we don't need to forget. Oh, this is the NS. So 1. In fact, B is just that, like. So if 3 girls are chosen at random, find the probability that more than one will have black hair. So probability that black hair will be greater than 1. That is, how many black hair? 7. So more than 1, meaning we'll start from 2. So if there are 2, then from 17 you just need 1. Or from 7 you get the whole 3. Meaning from 17 you get 0. And divide everything by 24. So 7 to 2, that's 7 factorial 2, 5. Multiplied by 17. 17 to 1 is just 17. Plus 7 to 3. So we get 7 factorial over 3 factorial. 7 minus 3 is 4 factorial. Multiplied by 17. Taking to 0 is just 1 in fact. So need not set anything, yeah? So this will divide by 24. What's remaining now if we simplify this? That is 7 factorial is 7 by 6 over 2 by 17 plus 7 by 6 by 5 over 3 by 2. Everything over 24. So here 6 go. Here we get 3. So 21 by 17. Giving us 357 plus 35 over 2024. 357 plus 35. That's 392 over 2024. That's greater than 1 back here. More than 1. So it can't be 1, it has to be 2 or 3. The last question in this stereo sheet. That's nice, eh? That's nice. Question 10. A coin is biased so that the probability that it lands showing heads, the probability head is equal to 2 over 3. Meaning that the probability tail is going to be 1 minus 2 over 3, which is 3 down, 3 minus 2, which is 1 over 3. If we add the two probabilities, you must get 1. For sure it is 1. A coin is tossed 3 times. So tossing a coin 3 times. Find the probability that, so the coin is tossed 3 times. Now when you toss a coin, you expect 2 outcomes that a coin. The first toss, head or tail. Again, head or tail. Again, head or tail. So if you toss, you get head, 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 or you get head, head, tail, or you get head, tail, head, or you get tail, head, head, or you get tail, 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 or you get tail, tail, head, or you get tail, head, tail, you get tail, head, tail. So three, so we just have three factorial, which is 6. 1, 2, 3, 4, 5. Okay. 1, 2, 3, 4, 5, 6, 7. Now repetition 9. Yeah, that is 14. 1 hour. So how many possibilities do you expect? If we are crossing 3 times, so we can get head, head, head. Yes. So we expect 8 of them. Yeah. Since we have 2 possible outcomes at 10 to the power 3, so it is 8. So remaining is 2 more. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Remaining is 1.
Sorry for taking you back.
Okay. What's your question? I think we need.
Sir, sorry if I had network problems.
Seems like you still have network problem.
I think so. The network. I don't know what.
Unless you have a question, but we are recording the session, so you don't need to worry much.
Oh, all right. It's fine. I'll go through when we're done.
Okay. Okay. So we have this combination. Now we got the question. 1. Find the probability that no heads are obtained. Find the probability that no heads are obtained. So where are we? The probability that no heads are obtained. Hey. The probability that no heads. Yeah. So no heads 1. There's only one possibility. Looks like there's only one. But remember, if it's 1, the possibility of getting 1 is 1/3. Of getting another one is 1/3. And another one is 1/3. So together we get 1/27.
Excuse me, sir.
Yeah.
I don't understand why you have to multiply 1/3 again, 1/3 again, 1/3.
I was saying that you want to check. Look, the question is asking us to see the probability of not having any head. Now, how many heads do we have? How many? It seems like every other probability has got a possibility has got heads apart from this one, the tail. But the probability of getting tail is 1/3. So it's like, and these guys are independent. The first toss does not affect the second toss. The only information we have is that in each toss, you only have 1/3 possibility of getting tail. That's why I'm multiplying the probabilities.
Okay, get you.
Yeah. So now we got, so this was A. Yeah, not one actually. Then B, more heads than tails are obtained. More heads than tails are obtained. More heads than tails. Only happens here, happens there, happens here, and happens here. The probability that heads are greater than tails. You've seen that we have 4 possible ways of doing that. But this is not a normal probability where we just say it's half, so we count 1, 2, 3, 4 out of the total. So in your first toss, remember in your first one, you have 2/3, 2/3, 2/3, or you have 2/3, 2/3, 1/3, or you have 2/3, 1/3, 2/3, or you have 1/3, 2/3, 2/3. That is 8/27 plus 4/27 plus 4/27 plus 4/27. So 8 plus 4, 12, 12 plus 8. Okay, 12 plus 4, 16, 16 plus 4, 20. So we get 20 out of 27. So look, if what we are doing makes sense, the other way of checking if what you are doing makes sense, you can add all the probabilities there. So the HH will give us 8/27 plus the HHT 4/27 plus 4/27, the HTH plus 4/27, the THH plus 1/27, the TTT plus 2/27, the TTH plus 2/27, the THT plus 2/27, the HTT. 27 is the common denominator, so let's add on top. So up to here we have 21, 22, 23, 24, 25, 26, 27. So we get 1. If the total probability is 1, then you know that what you're doing is very correct. That's why we answer that question. So nice. And in an easy way. Any questions? This is 21:16, and we are almost cut. So we'll have like a 13 minutes break. Same link, 21:30, we start. So don't go away, 21:30 we are starting. We're just going a bit.